This is a supplement to the previous episode about the bitter lesson for companies, and this is about the bitter lesson for careers. So what we want to continue with this thought. We thought it's better to have a new episode for that. So this is just a supplement to the one we just had about the bitter lesson for investing. The bitter lesson for careers is it's in line. Like if you think about, okay, if whatever works for AI is going to work for companies, and whatever works for companies is going to work for your career. So if you're an 18-year-old now studying at Berkeley, for example, so canonical example, you're at a top university doing a STEM degree at one of the best universities in the world. So you've already picked all the right box, checked all the right boxes there. So that's not the problem. I don't have to send you to another university, and I don't have to convince you to drop your psychology degree for something more useful. But even within the STEM field now, the question is, okay, what's going to be your next move? What's going to be your next decision? How are you going to decide whether you should do this or that? And the answer to that is follow the bitter lesson. So in other words, don't focus your skill set on immediate job goals. Okay? Try to leverage compute. Try to build a general skill set that will go with compute and also be adaptive. So what does that mean? For example, if you're a physics student today, I would recommend you focus on simulation. Simulation is something that scales with compute. It's going to get much better. And in my opinion, it will actually become the centerpiece of manufacturing. So what does that mean? So let's think about it this way. If we are building a rocket today, there's a lot of tinkering. There's a lot of stuff going on in the shop. And mechanical engineers, electrical engineers, welders, there's a lot of that kind of stuff going on. And there's a lot of workforce being used for that. So if you're a person that wants to work in rocketry, you want to, get a job at SpaceX or Rocket Lab or whatever. You want to be a hands-on person that can solve this. Andrew, my prediction is that 5 years from now, definitely 10 years from now, most of that shop, most of that tinkering will all be done in simulation, all be done in virtu. Jensen gave a very important speech about 2 years ago at actually a biotech conference where he spoke about drug design. And he said chip design used to be all the same way, in the shop, make your hands dirty kind of stuff. Today it's all in virtu. Nobody at NVIDIA actually makes their hand dirty anymore, maybe very few people. Most of them design in virtu, so companies like Synopsys, Cadence, ASML, or the whole supply chain has virtualized itself, so you can design chips in virtu, you can test them in virtu, you can simulate them in virtu, that's the key, and then tape them out at the end. So I think the same is going to happen to manufacturing. So as a STEM person, particularly if you're interested in something along the manufacturing front. But I think, by the way, manufacturing and AI and ComSci and all these things will actually more. There will be only one job which will be relevant, and I call it simulation, but you can call it also in virtu manufacturing or whatever you want to use the name for. People that build engines, physics engines, and people that know how to use them to manufacture a rocket in virtu. For example, the Starship rocket right now has certain problems to solve. The most important problem is the heat shield. Another problem that it has to solve is trajectory planning at very high speeds, particularly when you don't have full control because it's too far away. So those kinds of things need to be tested in virtu, because you don't have the luxury to send the rocket to Mars and see what's going to happen. You want to use that window and send it and hopefully have a successful mission. So if your career today is focused on in virtu manufacturing, in other words, simulation, physics engine, those kind of things, I predict you are actually leveraging the bitter lesson, you are leveraging compute, and you have a much better prospect for your job. So this would be a good example. Another thing which is important is you want to stay flexible. So you want to be able to pivot. What that means is that there's a sunk cost fallacy. It's always there for careers. It's there for companies. So maybe some things are like, Java, let's say, understanding code, fixing code could be maybe obsolete, and it's probably already obsolete. But what's not obsolete is designing the right architecture. What's not obsolete is evaluating code, finding ways to build engines that evaluate code. So code itself will become an in virtu process where you actually don't type stuff anymore. You let it do it itself. So you need to find evals. The same, by the way, with mathematics. Evals is one of the big. So evals will only grow with compute. So if you focus, instead of writing the code, on evaluating the code, if that's your skill set, I would say that, and then evaluating the evaluators and finding benchmarks, those kinds of things will grow with compute and get better. So to summarize again, think about your career as a bitter lesson applied to your career. Think about investing as a bitter lesson applied to investing, and think about AI as a bitter lesson applied to AI. Thank you.